Okay, so how do I graph a line? Well, by hand, first of all, you have to have y all by itself in the equation, which it already is on these, so that's no problem. Secondly, the number that is not being multiplied by x, that one tells you, let's see, I want to do this, do my cool thing like that. That one tells you what your y-intercept is, or in other words, where your line is going to hit the x or the y-axis. So it's going to hit at -7. Okay. Now the slope is 2. Slope is always the number multiplied by x when y is by itself. Well, it's easier to, if you're going to graph by hand, it's easier to graph if the slope is written as a fraction. So I put a 1 underneath it. So that means go up 1, 2, and then over 1. So the top number tells you how far to move vertically, the rise, and the bottom number tells you how far to move horizontally, the run. So up 2 over 1. Okay. So now, then I just play dot to dot, which is the payoff. It's super fun. And there's the line. And that's all you do every time. As you get good at it, it goes very fast. Okay, so now we want to find the x and y intercept of the line. Well, when we get to y-intercept is to solve for y. And then you can just tell what it is by looking at it, just like we learned, like the -7 in the last problem. I'm not going to do it that way. I'm just going to think of it this way. Well, I don't know what the line looks like, if it's increasing, decreasing, or what slope is, but I know that if this were the line, that would be the x-intercept. Or if that were the line, this would be the x-intercept. Or if that were the line, this would be the x-intercept. X-intercepts are always on the x-axis where y is 0. At height 0, they're not up here. X-intercepts are not up here at a positive height or down here at a negative height. They're on the x-axis where y is 0. So if you, oh no, I'm sorry. X-intercepts are on the x-axis where y is 0. So if you want to find an x-intercept, replace y with 0. So I get this. In the equation, I replace y with 0, and then I solve. I get 5x plus 0 is -13. 5x is -13. Divide by 5, and I get -13/5, which is -2.6 if you want the decimal. Okay, and that makes sense that I got the x-intercept because at the very end, I've got x equals. Okay, if I ended up with y equals, then I'm probably looking for the y-intercept. So let's go find that y-intercept. Y-intercepts are on the y-axis where x is 0. They're not to the left of the y-axis. They're not to the right of the y-axis. So if you want to find a y-intercept, you replace x with 0 and then solve for y. Okay, so -13/6, that'll be the y-intercept. And it makes sense, not just for the reasons I said before, but if you're looking for the y-intercept, then shouldn't your results say y equals a number? Okay, so when you're asked to find the y-intercept and the x-intercept, you just plug 0 for x, solve, 0 for y, solve, and it'll give you what you're looking for. Okay, the one that says x equals, that's going to be the x-intercept. The one that says y equals, that'll be the y-intercept for the reason stated on the graph. Okay, so let's see if we can figure out what kind of lines we have here. Now, we read graphs from left to right, just like reading a book. So from left to right on this one, well, let's start with this one, line number 2. From left to right, is the graph going up or down? Well, from left to right, it's going down. So it is going to have a negative slope. It is a decreasing line, a decreasing function. It has a negative slope. On this one, from left to right, it's going up. Okay, it has a positive slope. On this one, it has, well, can you imagine driving on this thing? Okay, I'm gonna draw a primitive looking car. Okay. If you're driving on that, it's a perfectly flat road. Okay. And you know, maybe some joker would put up a sign along that road and it says, warning, 0% grade. Okay, because it has 0 slope. Now, can you drive on a road like that? No, it's perfectly straight up. There's just no way to get traction. Therefore, it's undefined. It doesn't work. Okay, so now let's find the slope of the line. Well, from left to right, it's going up, so we know that it's going to be a positive slope. That we know already. And they specify 2 specific points, and we're going to read them from left to right. And so to get from this point here on the left to this point on the right, how far do we travel in the vertical direction? Well, we go 1, 2, 3, 4, 5, 6 units up. So, and m is our variable for slope. So we rise 6, and then how far do we run? 1, 2. We run 2, whoops, and we get a slope of 3 or 6 adds, you know, whatever. And that is all that you really do. Let's do one more of those. So working from the left point to the right point, we are going to rise -1, 2, 3, 4, 5. So our rise is -5, negative because we're going down. And then our run, 1, 2. And then this doesn't simplify, so we'll just leave it, -5 halves. And that is how we answered that one. Okay, so now we're going to find the slope again, except this time they're not giving us a graph. And I'll be honest, I prefer the graph because I think it's easier, but this isn't too bad. So remember, what we did a moment ago is we said, all right, well, we got, you know, rise on top, run on the bottom. And so how far are we going to rise? Well, we start off at height 2 and we go up to height 6. So we'll do our second y value minus our first, and that tells us that we're rising 4 units. Okay. What about the run? Well, for the rise, we found the difference of the y coordinates. So for the run, we'll find the difference of the x coordinates. So I'll do the second x minus the first. Okay. And we have a slope of 1/4. And that's the formula. The formula is going to be the second y value minus the first divided by the second x value minus the first x value. That is the slope formula you'll find in all major literature everywhere. Okay, so now let's graph a line with y-intercept 2 and with slope -2/5. So first of all, I'm going to need my coordinate axes. There they are, perfectly oriented, I suppose. So we start off with the y-intercept. We have to have a starting point. So the y-intercept is going to be at 2. And the slope is -2/5. Now, does the negative sign get attached to the rise or to the run or what? Turns out it doesn't matter. Put it on either one, but not both. Either one is fine. I usually put it on the top number, but it doesn't really matter. So I'll rise -2, and then I'm going to run 5 and end up right there. And there's my line. And from left to right, it is dropping, just as the negative slope suggested would happen. That's it. So you always start with your y-intercept, and then use the slope to find a second point. Then you get to play dot to dot. And it's super awesome. Okay, on this one, our answer is going to be an equation. Okay, the equation of the line. And it'll be in slope-intercept form with y by itself. Now, I don't need the coordinate axes, but yeah, it's kind of nice to do it. So it says we've got a point. It goes through 8, 5. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. So it goes through that point right there. And it has a slope of -3/4. So we're gonna go down 3. So 1, 2, 3, about there. And then over 4, 1, 2, 3, 4, to about there. And so the line is going to look about like that. Now they don't want the graph, but you know, it's not bad to practice. Okay, so what about that actual equation? How do we do it? Well, there's more than one way to do it. You can use the point, what's called point slope form of a line, which I don't. It's that formula there. And Alex will show you how to do it. I don't do it that way because I like to use this formula here because we already use it. So if I don't need to learn a second formula, why do it? This formula works just fine every time for what we're going to do, what we're being asked to do. Okay, so using this guy here, we're told that we have a slope of a -3/4. Okay, so y equals mx plus b. And we know that the slope is -3/4, so that's our m. Cool. And now what about, so all we got to do is figure out the y-intercept, the b, and then we're done. Well, they give us this point here, and that point says that, hey, whenever x is 8 for this particular situation, y must be 5. It just has to be. Okay, that's all there is to it. So I could say, all right, well, if I replace x with 8 and y with 5, then those two go together. Okay, they're an ordered pair. All right, so if I were to cancel the 4s here and then tidy things up a little, I'll get 5 equals -3 times 2, and then add 6 to both sides. And then the equation of my line, the final solution to this problem is y equals -3/4 x plus 11. And that's it. Okay. So do you think it's possible that as this line heads up towards the y-axis, that if I had drawn things perfectly, that it will actually hit the y-axis at height 11? I think that's possible. And in fact, that's the way it does work out. Okay, it'll hit up here at height 11. That's how you do those. Okay, so you plug in the slope for m, plug in the point that you're given, solve for b, and then you've got your y-intercept to plug into the formula, into the equation. Okay, so we're given an equation or a graph. We got to find the equation of the line. So we're looking for the equation of a line. That means y equals mx plus b. We can get the slope right away. We can say, all right, well, working from left to right, we would go down 1, 2, 3, 4, 5, 6. So down 6 and then over 1, 2, 3, 4. So our slope is -3/2. Cool, cool, cool. So all we need left is the y-intercept. Okay, well, I can tell the y-intercept looks like it's about 5.5. Okay, it probably is exactly 5.5, but you know, we don't necessarily know that. So let's do what we did on the last topic and plug in a point for x and y. We can use this point or this point. I'll just use the second one, which has coordinates of, what is it, -1, -4. Okay, so I'll replace x with -1. And if I do that, well, I have to replace y with -4 because those two guys are a team. They go together. All right, so we've got positive 3/2 there. And if we subtract 3/2 from both sides, that'll give us negative 2.5. No, that's not right. Negative 5.5. Okay, which is what we thought it was down there. And therefore, we're going to get y equals negative 3/2 x. We know that's the slope. And then minus 5.5, because we know that is the y-intercept. And it gives us exactly what we expected upon looking at the graph. Okay, on this one, we're looking for average rate of change. Now, the rate of something, if you look at a rate is always comparing two things, like how many eggs do I get per dollar? Per means divide, always does. Or how many dollars per gallon? Or how many miles per gallon? Each one of those is a rate because you're comparing two different things. Okay. So now in this case, we're talking about meters per second. That's kind of like miles per hour, except just using different units of distance and time. So we're looking for speed. In this case, the rate represents speed. So what is the average speed? Because the speed is probably not remaining constant. At least that's certainly the case in my car. When I first start up, my speed is slower than later on, and then it's constantly fluctuating because I have an old car and I don't have cruise control, which is fine. I hardly ever use it anyway when it's available. So anyway, so we want to know the average rate of change. Okay, all you're doing is finding the slope. Okay, as it turns out. For part A, you're finding the slope between the 0-second mark and the 3-second mark. So for part A, I'm only looking at those two. And so for that one, for those, the average rate of change is just going to be the slope between them. So the difference of the y values divided by the difference of the x values. So we get 26.1, and because we did meters per second, it will be meters per second. Right. Now, what about the second one? Second one says we're going to go from our average rate of change is going to be from the 4-second mark to the 6-second mark. So we'll go the difference of the y values. 7, 6, over the difference of the x values. Type it away here. Might as well. And we get 18.9 meters per second. Okay, so clearly the speed was not constant, which is normal. Yeah. On average, the race car was going faster between the 0-second mark and the 3-second mark. Okay, versus the 4-second mark and the 6-second mark. So that's average rate of change. It just comes down to find the slope between the two endpoints of the interval.